So in this video, I'm going to be talking about what eventually became the basis for the final design for my filter and the development towards that, which came around from the CEM3320. And the CEM chips were designed by Doug Curtis as ICs to be used specifically in synthesizers. The 3320 is aimed at filtering specifically. And the way it does this is it has voltage controlled amplifiers on various input pins, which then have a pin for a capacitor input and then an output as well. There were then resonance inputs, a resonance control, power pins, and a cutoff control. And that makes up the basis of the chip. So I started off by looking at the low-pass filter from the datasheet, but whilst looking around to see if I could find anywhere that explained this slightly better, I found that on Electro Druid's website, they had the exact same schematic but laid out in a slightly different way, which made it easier for me to understand what was happening, because here you can very clearly see the different stages of the filter. So here's the first stage, second stage, third stage, and fourth stage, because this is a cascade filter rather than the ladder filters I'd previously been looking at. So that was the low-pass version I found on Electro Druid's website, and this was the high-pass version. Initially, I was struggling to find any information on how you actually control the ICs. So I think it was the resonance input you could control with just the basic plus 5 volts to 0 volts, and that would give you all the control you'd need. But then the actual CV, or control voltage for the frequency cutoff, worked slightly differently. And I did manage to find an existing schematic that had both the resonance and the frequency cutoff controls already laid out. So in my final design, I used them in a similar way, but I have made some fairly large modifications to this schematic, which was the Sequential Pro 1. Specifically, it is a clone that's designed to run at plus and minus 12 volts rather than the original 15 volts. So I was very lucky to be able to find this schematic. But moving on, I started by going over the low-pass filter, which was actually the more complicated of the two filters, as you needed to implement tie-down resistors coming from the different stages to minus 12 volts. And that's just to help keep the whole signal centered around 0 volts. Additionally, one of the large modifications I added was this switch here, and it's split into two parts because it's a double pull, double throw, so it made the most sense to have the two halves in different places. And what this switch does is it changes the slope of the cutoff frequency. So typically with a 4-order filter, which this would be with all of the stages, it's a minus 24 decibel slope, whereas when you flick the switch, it changes it from 4 orders to just 2. So it is then a minus 12 decibel slope, which gives a more gradual cutoff with the frequency, which could be very useful. The high-pass version is then very similar, although changed around slightly to accommodate the actual circuit here. So I used this with slightly different valued capacitors and resistors for my final schematic, but the layout of the components was the same. So again, this was the low pass filter half that I decided to use because, as you may remember from when I spoke about my ladder filter I designed, I was actually using two, and one was a dedicated low pass, the other was a dedicated high pass. And I intended on doing the same again here because that would give me much more control over the individual parts. Because, as I mentioned earlier, with it being, or with the controls having a voltage controlled amplifier, instead of having, say, like a Vactrol, which I talked about in some of the much earlier videos, these create a voltage difference in a much different way, and you can control them, or because they're voltage controlled, that is technically where your frequency control comes from. You are using it to control these amplifiers. So by doing that, you can then stack as many of these chips all off of the same control as you like in theory, and it would just work exactly like that. But you wouldn't be able to adjust them individually. You'd be adjusting all of them at the same time. And then that led on, and that's half the main reason why I chose to use the split high pass and low pass with this actual circuit. Otherwise, I could have done a hybrid filter similar to the Elka Synthex multimode filter, which has different, or can be switched to either run as a high pass, low pass, or band pass. Whereas with the two ICs that I've done, I'd be able to have high pass, low pass, band pass, and band reject. But I also intended to use the series and parallel switch as well as the bypass switches that were shown in my vacuum tube filter. I think that concludes everything for this specific section of the filter. So in the next video, I'll be explaining the final schematic I came up with using all of these parts.